Good morning, dear students. Uh, I'm Mukund Soni, and I welcome you all for the chemistry class of class 10. Welcome to chemistry class. That is for your class 10. Date is 7 December 2020. Let us understand what we have studied in the last period, my dear students. In the last period, we have studied about the isomerism into the various compounds. So first, we should know what is isomerism. Isomerism is the phenomena of having isomers. What are the isomers? Isomers are the compounds that have same molecular formula but different structures. They are known as isomers. Isomerism is of three types. One is known as chain isomer, another is known as the position isomerism, and third one is known as the functional isomerism. Let us first study about, or let us first revise about the chain isomerism. So let's have a look to the chain isomerism. In chain isomerism, if we study, then we can come to know that they have different chains. They have different chains means different arrangement of this carbon. You can see here and this. We have this 5 carbon, and this 5 carbon we have arranged in a different manner. So this is what it gives us, the chain isomers. So what we can write for chain isomerism, same molecular formula but different carbon chain. So the first example that we have is known as the normal pentane, which is nothing but CH3, CH2, 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 CH3. All the carbons are arranged in the same sequence. Then you have the another compound which is known as the isopentane. This isopentane has got one carbon out of its line or out of its sequence. And then, my dear students, if we look at the third arrangement, which is known as the neopentane, where three carbons are in a straight line and another three carbons are horizontally attached to this. So if we write their IUPAC name, my dear students, if we really write their IUPAC name, we will write pentane for this. We will write 2-methyl butane for the isopentane, and for neopentane we should write 2 comma 2 dimethyl propane. So this is how, my dear students, we can write for the neopentane. Now if you really look at the number of carbon and number of hydrogen, there must be 5 carbon and 12 hydrogen in each of these compounds. So let us see, you can see that 1, 2, 3, 4 and 5 carbon, then 3 plus 3, 6 plus 3, 9 plus 3, 12 hydrogen. Same way if you look at here, 5 carbon, 1, 2, 3, 4, 5, 3 plus 2, 5 plus 1, 6 plus 3, 9 plus 3, 12 hydrogen. And here even if you can see 1, 2, 3, 4, 5 carbon, 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 3, 12 hydrogen. So this is how, my dear students, we truly understand about the isomerism, which is known as the chain isomerism. Now, my dear students, we want to study about the another type of isomerism, which is known as the position isomerism. So let's study about the position isomerism. See, in position isomerism, what we find is different position of the functional group or branch. The position of the functional group or the position of the branch is different. So now you can see that we have the compound C3H at O. So you can see that we have carbon 1, 2, 3, C3, hydrogen 1 plus 3, 4 plus 1, 5 plus 3, 8. Here also carbon 1, 2, 3, hydrogen 3 plus 2, 5 plus 2, 7 plus 1, 8, and one oxygen is present in both the compounds. So here you can see that this branch, which is hydroxyl group, or this is the functional group, is bonded here to the first carbon, and here it is bonded to the second carbon. So we call it 2-propanol, and this we call it 1-propanol. Both are the position isomers of each other. So we call both of them as the position isomer of each other. Same way, my dear students, you can see that the here CO group is present on the third carbon, and here CO is on the second carbon. That is why it is 3-pentanone, whereas this is 2-pentanone. The molecular formula is same for both of them, that is C5H10O, and that is why these two are again the position isomers of each other. Same way, my dear students, if you look at 1-butene and 2-butene, you can find that both the butenes have 4 carbon and 8 hydrogen, but the position of double bond, here it is between the first and second carbon, and here it is between the second and third carbon, and that is why it is known as 1-butene, while it is known as 2-butene, and they are the position isomers of each other. Same way, if you look at the 1-butene and 2-butene, my dear students. Here the triple bond is present between the first and second carbon, and here triple bond is present between the second and third carbon, and that is why it is known as the 1-butene. This is what it is known as the 2-butene, and this is how they are the position isomers of each other. Now, my dear students, we want to study about the third type of isomerism, which is known as the functional group isomerism. So here the compounds have same molecular formula but different structures due to the different functional group present in them. Such isomerism is known as the functional group isomerism. Let's have a look to this. So if we look at the first compound, which is CH3, CH2, CHO, it is propanol, which is aldehyde. So the functional group present in this compound is aldehyde. It is propanol. If you look at the number of carbon, 1. If you really look at the number of carbon, 1, 2 and 3 carbon. Number of hydrogen, 3 plus 2, 5 plus 1, 6 and 1 oxygen. Same way if you look at this compound, which has ketone as a functional group, you can see here that the number of carbon is 1, 2 and 3 carbon. Number of hydrogen is 3 plus 3, 6 and 1 oxygen is present. So both this compound have same molecular formula C3H6O, but they have different functional group, and that is why both the compounds are known as the functional group isomers of each other. Same way, my dear students, if you look at the propanoic acid, CH3, CH2, COOH, if we count the number of carbon 1, 2 and 3, so 3 carbon, hydrogen 3 plus 2, 5 plus 1, 6 and 2 oxygen you can see here. Same way if you look at the another compound, here you can have carbon 1, 2 and 3, C3. If we look at hydrogen 3 plus 3, 6. And if we look at oxygen, here we have 2 oxygen. So both the compounds have molecular formula C3H6O2. But if you really look at the functional group. The functional group here is carboxylic acid, whereas the functional group here is ester, and that is why this is the carboxylic acid, whereas this is which is propanoic acid, whereas this is the methyl ethanoate, which is an ester, and this is how we can simply understand about the functional group isomerism. So, my dear students, this is the way we understand about the various kinds of isomerism into the carbon compound. If you have any doubt, you can ask me or you can even WhatsApp me your doubts. Now let's move to the nomenclature of the carbon compounds. So here we should study about how to give names to the various carbon compound. Name of the carbon compound may have three parts. So we can divide the name of the carbon compound into three parts. First part is known as the word root. Word root is determined from the number of carbon present in the longest chain. So we can determine the word root by determining the longest chain of the compound. And it depends upon the number of carbon present into the compound. Then we have the next one, which is known as the suffix. So if we have suffix, that comes from the functional group present into the carbon compound. So if the functional group present is alcohol, the suffix is going to be ol. If functional group is aldehyde, the suffix is going to be ar. If functional group is ketone, the suffix is going to be on. If functional group is carboxylic acid, the suffix is going to be oic acid. If functional group is alkane, we will have suffix ane. If functional group is alkene, we will have suffix ene. If functional group is alkyne, the suffix we are going to have is yne. So C single bond C, ane, C double bond C, ene, and C triple bond C, yne. Now, my dear students, we want to study about the prefix. Prefix is determined from the branches. Let us understand. Suppose we have a compound here with us, which is known as the methane. Look at this compound we are talking about. We are talking about this compound, which is known as the methane. Now, suppose if we have CH3Cl, so one hydrogen is replaced by chlorine. You can see here. Sorry. So here, instead of just writing methane, we add one word chloro before methane, and we call this compound as a chloromethane. The name of this compound is chloromethane. Why do we call it chloromethane? This chloro is known as the prefix. And this prefix is because of this branch of chlorine. So this is how, my dear students, you can understand that in the name of this chloromethane, this chloro part is your prefix, this meth is your word root, and this ane is your suffix. That is because all the bonds are single bond and we put ane. Now suppose we have CH2Cl Br. So we need to follow the alphabetical order. Please learn this. That if you have more than one branch, then you need to follow the alphabetical order. For this, you will write chloro. For this, you will write bromo. But my dear students, B comes first into the alphabets before C. So we need to write it bromo first and then we should write chloro. So my dear students, while writing prefix, the correct name we will write is bromochloroethane. For this compound, if you have bromine and chlorine both present at the same time, we should write bromochloroethane, not chlorobromoethane. Remember, we should not write chlorobromoethane, but we should write bromochloroethane. Same way, my dear students, if you look at this compound, here it has no hydrogen, but it has a bromo, it has a chloro, it has a fluoro, and it has iodo. So if we try to arrange them in alphabetical order, first comes bromo, then it comes chloro, then fluoro, and then iodo. So we'll write bromo, chloro, fluoro, iodo, methane. So now we will call this as a bromo, chloro, fluoro, iodo, methane. It is bromo, chloro, fluoro, iodo, methane. This is how we write it. Same way, my dear students, here if you want to write the name of this compound, which is in front of your eyes on your screen, you can see that we have carbon 1, 2, 3 and 4. So 4 carbon, that is why we will write but. Then you can see that on third carbon we have methyl group, on second carbon we have chloro group. Functional group is alkane because all bonds are single bond, all single bond. So we will call it functional group alkane, and that is why we will use the suffix ane, and then we can have on second position chloro and on third position methyl. So what we should write here, 2 chloro, 3 methyl butane, but we should not write 2 methyl, 3 chlorobutane. If we start giving numbering from here, we will give 1, 2, 3 and 4. So we have two ways to give the numbering, but this numbering is correct and this numbering is considered as a wrong because by following alphabetical order, chloro come first, C come first and then M into the alphabets, or by following the alphabetical order, we will give preference to chloro. So chloro should be on second position and methyl on third position, and that is why we will write 2 chloro 3 methyl butane, and we will not prefer this 2 methyl 3 chlorobutane. It is going to be the wrong name for this compound. So while naming the compound, my dear students, we need to understand all these things, or we need to keep all these things in our mind. Now, my dear students, we want to study few more names. So let us look at this compound. When you look at this structure, you can write the names or numbers 1, 2 and 3. Now alcohol, OH group and chloro both are present on second carbon. If you number from this side or that side, these groups are present on second carbon only. Now this OH is your functional group, and that is why the suffix is going to be all. This is your chloro, which is going to be a branch, and it is used as a prefix. So now, my dear students, you can easily understand it that you have prefix, you have suffix, and you have 3 carbon. So for 3 carbon, you write prop or propane. Then you add all. From propane, you remove this E and add all. Please remember that you remove E and add all. The propanol, the hydroxyl group is also present on second carbon, so it is 2 propanol, and on the same second carbon, chlorine group is present, so it is 2 chloro, 2 propanol. This is how, my dear students, we understand the nomenclature. Same way, my dear students, if you look at this compound, you will realize that it has 5 carbon. So I have numbered it 1, 2, 3, 4 and 5, and 1, 2, 3, 4 and 5. If I give numbering this way, fluorine is there on third carbon. Even if I give the numbering from this side, fluorine is on third carbon. And from this side, chlorine is on fourth carbon, and from this side, chlorine is on second carbon. Now, C, A, B, C, D, E, F, G. So C comes first. So priority should be given to the chloro, and chloro should get the minimum number, and that is why this way of giving number is considered to be the right way. So by giving priority to chloro, we write it as a 2 chloro. This is 2 chloro, 2 chloro, 3 fluoro, and 5 carbon, so pent, and there is no double bond, so ane. It's a 2 chloro, 3 fluoro pentane. Same way, my dear students, if you look at this, there is a double bond. There is a chloro. If you give number even from this side, the chloro is always there on the second carbon. But here it is from the first, the double bond is between first and second carbon. If I give numbering this way, the double bond is between second and third carbon, and that is why this is wrong. This is the right way to give the number. Now, what name should I give? So as the double bond is after first carbon, it is prop E and E. Total 3 carbons, so prop, then E and E, and on second carbon, 2 chloro, so 2 chloro propene, or even you can write it as 2 chloro prop 2 in. So this is how you can give names to these various compounds. Let's move forward and understand the next compound that we want to study about. Let's have a look to this carbon, this compound. Let us study about this compound. See, when we study about this compound, my dear students, we can see that there are 1, 2, 3, and 4 carbon present. So the suffix is going to be, the word root is your but. When we look at the chloro group, 2 chloro group is present on the second carbon. If I start giving numbering from this side, it is going to be third carbon where 2 chloro group is present. But if I give numbering from this manner, it is the second carbon where 2 chloro groups are present. So we will consider this as the correct manner, and we will not consider it as the way of numbering. So this is the correct way of numbering. We have 4 carbon, there is no double bond, so it is definitely butane. But what kind of butane? It is dichlorobutane, because 2 chloro group are present. As 2 chloro group are present, it is dichloro. If 3 chloro groups are present, we will call it trichloro. If 4 chloro group are present, we will call it tetrachloro. So this is how, my dear students, we do this various kind of changes and we understand the nomenclature. Now let's look at the another carbon. Now look at this. This has only 1 carbon, so it is methane. But how many chlorine? 2. So it is dichloromethane. If it has got 3 carbon, 3 chlorine and 1 carbon, it is trichloromethane. If there are 4 carbon, 4 chlorine with single carbon, it is tetrachloromethane. So this is how, my dear students, we understand the nomenclature when we have more number of groups are bonded to the carbon. Now you need to remember this, my dear students, that when we have this kind of compound, they have got 2 type of names. See, if we have simple CH3Cl, we would write it as a chloromethane. We don't need to write really mono before it. So we can simply write it as a chloromethane. Then 2 chloro, then dichloromethane, 3 chloro, trichloro, 4-chloro tetrachloro. Now suppose we have iodine. So it is triiodomethane, 3-iodine triiodomethane. Now these are called the IUPAC names. But apart from that, they have got the general names also. So please learn this general name, my dear students. This CHCl3, which is also known as chloroform. Same way CHI3 is known as iodoform. And CCl4 is known as carbon tetrachloride. Please learn these names and learn this idea of understanding this compound. Now we have the next compound to understand, my dear students, that we have CH and both the side Cl2. See, this is CH, this is CH, and then you have Cl bonded to this carbon, 2Cl bonded to the same carbon. You can even represent it in this manner. This is what I am going to show you, the structural formula. Each carbon is bonded with the one hydrogen and you have 2Cl bonded to it. You can write the same as this CH, Cl2, CH, Cl2. This is the condensed formula. So here you can see that this is the first carbon, this is the first carbon, this is the second carbon. On first carbon we have 2 chloro. So 1 dichloro, and then on second carbon even we have 2 chloro. So we will write it as 1, 1, 2, 2, 4 chloro, so tetrachloro, and 2 carbon, so methane and ethane. So ultimately we will call this compound as 1122 tetrachloro ethane. Why ethane? Because it has 2 carbon and all the bonds are single bond. So this is your word root and this is your suffix. Here you have this part which you call it as a prefix. So please understand, my dear students, this is how we can give names to the various compounds. You even need to understand the various common names given to the compounds also. I hope, my dear students, you, uh, you are enjoying your studies. Now we want to study about the properties that change along the homologous series. So how do the properties change in the homologous series? In homologous series, as the functional group remains the same, chemical properties of all members are same. Remember that all the members present in the same homologous series have same chemical properties. But physical properties changes. Now which are these physical properties? Melting and boiling points increases as the number of carbon increases. So as you go down in the homologous series or as the number of carbon increases, melting and boiling point increases. Because as the number of carbon increases, molar mass increases and that is why the melting and boiling point increases. So if you are asked in the exam that in homologous series, as the number of carbon increases, why melting and boiling point increases? You can simply answer that as the number of carbon increases, the molar mass of the compound increases and that is why melting and boiling point increases. Then another physical property which is known as the solubility in a water or solubility in a particular solvent. So when we go along the homologous series, solubility in a particular solvent also changes as the molar mass increases or as the number of carbon increases, solubility in a particular solvent changes. For example, as the number of carbon increases, solubility in water solubility in water decreases, my dear students. Please remember that as the number of carbon increases, or as the number of molar or as the molar mass increases, solubility in water decreases along the homologous series. Now, my dear students, we want to study a next question, that is, what is organic compound? So there is a particular definition for the organic compound. Compounds of carbon other than oxides, carbonates, bicarbonates, carbides and sulfides of carbon are known as the organic compound. Once again, compounds of carbon other than the oxides, carbonates, bicarbonates, carbides and sulfides are known as the organic compound. So organic compound is nothing but the compounds of carbon. That is what we can understand. Now, my dear students, there was a theory about the organic compound or carbon compound, which was known as the vital force theory. Let us see what is the vital force theory. So, according to the vital force theory, organic compounds or compounds of carbon can be synthesized within a living system only. मतलब ये कहना चाह रहे थे कि जिंदा लोग जो हैं उनके शरीर में ही कार्बन कंपाउंड्स बन सकते हैं, ऑर्गेनिक कंपाउंड्स बन सकते हैं. According to the vital force theory, organic compounds or compounds of carbon can be synthesized within a living system only. It was postulated that some vital force is needed for the synthesis of organic compounds. It was postulated that some vital force is needed for the synthesis of the organic compound. So, my dear students, this way we can understand the vital force theory. I hope you are enjoying your studies. Happy learning.